Solve. Determine the approximate value of x. We have e to the negative 3x power equals 5 and 2x equals 44. How am I going to find the approximate value of x in each one of these equations? My teaching assistant Chloe is here with her latest tips and tricks. She wants you to know that when you see log of a, there really is a 10, we just don't write the 10. So if you have log of 10 and you have a base of 10, because we don't write the 10, those actually cancel each other out and it gives you a 1. Just like when you have natural log of a, there really is natural log of e, we just don't write the e, or you could write it as log base e, we just don't write the e. But when you have natural log of e and the base is also e, they cancel each other out and leave you with a 1. Now the product property of logs is when you have log of m times n, you can go ahead and expand that out into log of m plus log of n. The quotient property of logs is when you have log of m divided by n, you can expand that out to log of m minus log of n, where n cannot equal 0. And the power property of logs is when you have log of n to the p power, you can actually pull that exponent p out in front to p log of m. Now that we have Chloe's tips and tricks, we can go ahead and find the approximate value for x in each of these equations. So on this first equation, I have e to the negative 3x equals 5. I'm going to go ahead and use the rules of logs and natural logs to go ahead and solve this, since logs and exponentials are inverses of each other. So I'm going to go ahead and take the natural log of e and then the natural log of 5. From here, I'm going to go ahead and use the power property of logs, that when I have an exponent, I can pull it out in front. So instead of negative 3x in the exponent, I'm going to have the negative 3x in front of the natural log of e, and that is set equal to 5. Now remember, when we have natural log of e, we really have a base of e, we just don't write it, but I'm going to write it in here to show you, because what happens when we have the natural log base e of e? That actually ends up equaling 1. So from this part right here, this natural log of e, natural log of base e of e, this is actually going to end up equaling 1. So I'm just going to go ahead and take that negative 3x and multiply it by 1, set that equal to natural log of 5. Negative 3x times 1 is negative 3x. Now I am solving for x on this problem, so I'm going to go ahead and divide by negative 3 on both sides. When I do that, negative 3's will cancel on the left. That ends up giving me x equals natural log of 5 divided by negative 3. Now, I'm not trying to find the exact value. It wants me to find the approximate value, meaning I'm going to have to use my calculator. So when I use my calculator and I take the natural log of 5, I get 1.609 and a bunch of other numbers. And that is all being divided by negative 3. I'm not going to round it till the very end, and I'm going to just round it to 4 decimal places. So when I divide 1.6094379124341 divided by negative 3, I get negative 0.5365 as my answer. Now let's go ahead and look at this other problem. We have 2x equals 44. Again, I'm going to use logs, since logs and exponentials are inverses of each other. So I'm going to take the log of 2x and the log of 44. Now that x is in that exponent position, and I can use the power property of logs to bring that p out in front. So I'm going to go ahead and take that x, bring it out in front, and I get x log of 2 equals log of 44. From here, I am trying to solve for x, so I'm going to go ahead and divide by log of 2. Whatever I do to one side, I have to do to the other. So I end up getting x equals log of 44 divided by log of 2. Now on this problem, they're not asking for the exact value, they are asking for the approximate value. So I'm going to go ahead and use my calculator, and the log of 44 is 1.6434, and log of 2 is 0.30102, etc. I do not round until the very end, and you should get into that habit as well. So when I take this 1.64 number divided by the 0.3 number, I end up getting x is approximately equal to 5.4594. And those are my final answers when I am looking for the approximate value of x in each of these equations.